Hey everyone, so in this video I want to talk a bit more about controlling the RBD material fracture. Because as you've seen so far, it's kind of tricky to control where exactly the pieces are and how dense the areas are and so on. It's kind of random. And in this video I want to talk about how to be able to control a bit more to art direct where the pieces should be. And mainly we want to talk about two ways of doing this. The first one is by painting the more denser areas. And the second one is by defining the points or also the geometry that we want to use to fracture our geometry. All of this again is for the RBD material fracture specifically. If you want to use the Voronoi or as we will see the Boolean fracture, these techniques will not apply. There are other ways of controlling those. So let's get right into it. Small note, this was actually originally split in two videos and I combined them now into one, and this is why the editing sometimes is a bit weird, just keep that in mind. And let's start with the RBD paint. So what we've already seen is that the RBD material fracture can speed up the fracturing workflow and create some really nice fracturing by controlling the fracturing with the volume, and we can visualize that volume here with primary volume, and then it shows you. And let's simplify this with just one fracture level and maybe 100 pieces. You can see that only in those areas where it's red, basically there will be more fractures, and it's not that easy to see, but when you use an exploded view, for example, it's pretty clear, there you go, that in those areas there are smaller and more pieces. Of course, we can change this. And let's quickly stop the visualization, because what I already turned on is the visualization for the name attribute. And when we visualize the primary volume, of course, we can always go down here to the fog volume and change, for example, the noise offset, and then we get a different result, or maybe we change the frequency, all that stuff to change where our denser areas are. The problem, of course, is I have no control over this. It's more like luck to find what I want. And this is where the RBD paint comes in, because it allows us to paint an attribute that defines where the breakup should be. So by just pressing enter, you get a normal control cursor here. And when I paint it, just like with the attribute paint, you can see I can paint, values onto my statue here. And the logic is very similar to the attribute paint. I can use the right button to paint the background value and the left mouse button to paint the foreground value, so 1 and 0. And with Control Shift, I can control the size or the radius of my cursor. And I can change the opacity, so it's additive, and this way I can paint where I want the most pieces to be. So let's do something like this. I take away everything from the bottom and only paint it at the top, something like this. Pretty straightforward. So what it's doing actually is simple. It paints two attributes, the density and the visualization fall off. The visualization fall off doesn't matter. This, like the name suggests, is only for the visualization in the viewport, but it paints an attribute called density. Not the most clever choice if you ask me, because density, as we know, has a different meaning in the RBD context as well, but fair enough. But this is what we have just painted. And what we can do now by connecting those to the RBD paint with the RBD material fracture, by default it doesn't do anything. So if I turn off the visualization and turn off this visualization of the density as well, and maybe turn on the name attribute instead, you can see it's ignored. So by default it doesn't take this attribute into account, but what we have to change is down here where we set the cell points. We switched from using a volume to using an attribute, and of course the density attribute is already set here as a default, and you can see now it works. The upper part where I painted my density attribute has more pieces and smaller ones, and on the lower part the density is lower. Now the thing is, this is not too hard to do. You don't necessarily need an RBD paint for this. You could just use an attribute paint for this. And all we have to do is we change the name of the attribute to density, and to prove that it's different. And actually it might be even better because it's a newer node, as you can see, with way more functions. But let's paint down here, let's say at the bottom, to get the opposite result. And let's speed this up a little bit by turning off the lighting. There you go. Now it's much faster. And if I would use this, as long as it created a density attribute on the points, I can use this as the input, and when I look at the result, by visualizing the name attribute, for example, and turning back on the lighting, there you go, I can see, it works the same way. I paint it down here, and this gives me more dense pieces down here and almost no pieces up here. So this perfectly works with an attribute paint. What's the point then of the RBD paint? Well, in a more complex case, this can be really helpful, because let's say we want to use a more complex example, and I know this is just a box by itself, it's not complex, but let's say we wanted to create a multi-stage fracturing. So this RBD material fracture, and we talked about this, we can actually combine with a second RBD material fracture. And when I go up here and say fracture per piece, then it will fracture every piece that is already fractured up here separately in the second RBD material fracture. So let's maybe lower the number of points here. I only have one fracture level here. And if I turn on fracture per piece, of course, what we can see is, maybe with an exploded view, that before the pieces looked like this. And again, let's visualize the name attribute. There you go. Those were my pieces from the first RBD material fracture, and this is now fractured again. I think it was 6 times, and then it looks like this. And maybe here I want to have more art direction between those 2 steps. And this is where the RBD paint comes in with some additional functions, because what it has already built in is an exploded view that you can use to then only paint into certain pieces that are already there. So for example, by pressing enter, I can now paint here, and I have to make sure that the density is visible. So let's turn off the name, there you go. So let's say I only wanted to break up the pieces that are inside of my fracturing. So this one, for example, or maybe this one, so 3 of them, and maybe, yeah, a little bit of this one, let's say. And I can use now, of course, this density attribute in my second RBD material fracture. Instead of volume, I use the attribute. It's called density. And what you can see now, when I switch my visualization from density to name again, actually nothing has changed. Still, every piece is broken up. And this has changed in Houdini 19. So this is a bit annoying, to be honest. When you just use the attribute, it kind of ignores it. It will not be used to control how many pieces will be broken, but only where the distribution is. So for example, if I visualize the density that I painted, this one is a good example. If I have a density attribute, it will use this to, it's annoying to go back and forth, but here we go. It will use it to define where the breakup is happening the most, but if it's not there, like in this piece, it will just evenly distribute the pieces. What we often want is we want to control if there is any breakup at all. And you can do this with the scaling next to it. And then unfortunately you have to say scale by attribute again. And thankfully it already has the density in here. So if you turn on both attribute and then again scale the scatter point number by the density, you can see this way you can only break up the pieces that you painted a density on. So you can control very specifically where you want an additional fracturing to happen. If you turn this off again, it will fracture everywhere, but you can still control the distribution of the fracturing, but you can't stop the fracturing. This is something you can do by turning on the scale by attribute, and then you can control it completely per piece. So you can see this is kind of specific to a multi-stage fracturing approach with the RBD material fracture, but it's good to know that you can do that to, extend your workflow. By the way, this of course doesn't work with the Voronoi fracture, because the Voronoi fracture doesn't have an option here to use an attribute to control the breakup. The best you can do is do something like a group to limit that, or maybe you build your own system that then creates the point based on some attribute, but this is beyond this course. This workflow only is meant to work in combination with the RBD material fracture. Now there's actually a second way of controlling our fracturing, and this is something we briefly looked at, and that is the fourth input here into our RBD material fracture. So let's have a look at that. So the first thing when you mouse over the fourth input is that it tells you it can be used for extra Voronoi points, impact points for the glass setup, and cutter geometry for a custom material. So let's go through those 3. The first thing we've already seen by default, it fractures objects based on the points that it itself scatters inside of a volume, which we can change. But if we turn this off, we can actually tell the system to also use input points from the fourth input. So for example, we can use a scatter to scatter on the surface of our box, maybe not that many points, maybe something like that. And those points will now be additional sources for a fracturing to, if for some reason you have those points from outside, you can now add to the RBD material fracture. The other thing we've seen is when you have something like glass, you can switch the RBD material fracture to glass, and then it creates randomly currently one scatter point, which we can turn off, and then use the points from outside again in the fourth input. Maybe again, not that many, but maybe something like 4 or something. And all you have to do is you turn on the input points again, and it will take those points from the fourth input to shatter your glass based on those points. What we haven't seen, as far as I remember, is the third option, and that is the cutter geometry. So what this does is it allows you to actually specifically define where the cuts are, not just where the pieces will be. So with a fresh RBD material fracture, this works by switching up here the material type to custom. And by default, it already creates then a couple of internal surfaces that it uses to, as you can see here, fracture our box. So what it does, you can actually visualize up here in the guide geometry that we've seen before and turn on cutter geometry. Then you can see what it's doing. By default, it currently scatters cutting geometry into a volume, and the type of geometry that it scatters is a grid. Of course, you can increase the amount, and then you have way too many. Let's say 3 maybe to understand it better. There you can see it. And it really just creates grids, as we will do ourselves in a second, positions them randomly, and then cuts the box with it. You can also change this to sphere, for example, and then you get those rounded fracturing pieces. Let's quickly turn this off for now, and then maybe with an exploded view, we can have a look at it. There you go. So maybe if that's something you want, so more like, rounded breakups. Let's actually increase the scatter points so that you have more of them. And then you can also increase the resolution with the frequency. And you can use the user input, which would then be what we want to look at now, which is the fourth input. So for example, let's start with a simple grid. And what it does when you turn on user input, it takes the grid that we just created, which we can see in a second, we can deform, and then it scatters this one randomly, which, like I said, can be interesting when you use a deformed version of that grid. But this is again scattering it randomly. What we want to do is we want to turn this off, this function completely, even though we can of course do some R&D with this, and we instead turn on the input cutting geometry so it uses directly, let's get rid of the exploded view, directly the grid we just created. But this is something where I have to stop now, because we will talk about this technique in the next video called the Boolean fracture, which this basically is, but I want to, give it a whole video so that we can talk a bit more about this technique, because it's the third of the 3 big approaches to fracturing. So I hope for now this was helpful. We looked at the RBD paint to really paint where we want our points to be denser or less dense. And also then we looked at the custom fracturing of the RBD material fracture, where we can use the fourth input to control where we want the fracture to happen, either by points or, like we've seen here, with additional cutting geometry. So for now, I hope this is helpful. Thanks very much and see you later. Cheers.